And what I want to do is talk about interest and then this number E that's going to come up. The book talks about it. And this number E, if you are going to go to the business school and take Math 28, you'll see it in that course. You'll see it in economics courses. If you go into study math, computer science, data analytics, anything like that, you're going to see that number E. If you take a Math 50 calculus, if you're going to go into pharmacy, if you're going to go into other sciences, you're going to see that number E. So I want to, if you haven't seen it before, I want to introduce it, and it's related to interest. So I want to talk about the moving parts of interest. We're going to have this is going to be the interest rate as a decimal, and it's going to be the interest rate yearly, and it's going to be as a decimal. And so I'll show you what I mean. If we had an interest rate is equal to 10%, then R would be, we'd write 10% as a decimal, and the way you do that is 10 has the decimal here, so you just move it over twice. And that would be how we express the interest rate. And that means that you're getting, if you multiply however much money you have, that you would earn 0.1 times that much money per year. So if you had $1,000, 10% per year, here's how much money you would have. You would have your original 1,000 plus your interest on the 1,000. That would be 1,000 plus 1,000 times 0.1. So that would be another $100. Now the way we usually express this is, since that you have that same number there, usually this is abbreviated like this. And so that would be how much money that you would have after 1 year. Okay, so that's R. You're going to see this term 1 plus R a lot, or variants of that. Then you have N, and that's going to be the number of times interest is paid per year. Again, I'll use 10% as an example. You get 10% per year, but it's paid, and they use the word compounded, monthly. You don't get 10% every month. You get 1/12 of 10% every month. So that would be, your monthly interest would be 1/12 of 10%, which is 0.1, or 0.1 over 12. That's your monthly interest. And so after 1 month, if you start with 1,000, after 1 month you would have that 1,000 times 1 plus 0.1 over 12. Okay. So it's not as much money as you think it might be. Okay. So that's the number of times. And so if you have if interest is monthly, N is equal to 12. If interest is quarterly, it's 4 times a year, N would be equal to 4. If your interest is compounded daily, your N would be 365. Okay. And that's the basics. Good. I think we're ready to go. So the formula that you see, so if you get your return on PO dollars invested for T years at R% yearly, compounded or paid N times a year. That formula is P of T, that's our function. Your initial investment, how much you would get paid N times a year, so it would be your rate over N, and then it would be times the number of times that you could get the interest paid. If it was 1 year, it would just be N. If it were 2 years, it would be 2 times N. And if it's t years, it's going to be n times t. So some quick examples. Your rate is 4%. Your interest is paid monthly. And your initial investment is $5,000. So this is, again, the interest rate is per year. Your formula would be P of t equals 5,000, 1 plus 0.04, 12, because that's the number of months, times t times 12. So P of 1 would be equal to 5,000, 1 plus 0.04 times 1 times 12, or just 12. 12 interest periods over 1 year. For 2 years, it would be 5,000. Again, the same interest. This is how much per payment. And then it would be 2 times 12, or 24. So if you get a problem, what the key is going to be is to figure out what your n is, and that's going to be given monthly. That's your n. Your rate, turn it to a decimal, how much you started with. And then you just plug and play. Okay, so that's pretty easy. Okay, I want to do one thing. I want to get to this number e. And this number e is defined like this. It's 1 plus 1 over n to the n, but you let n go to infinity. So I'm going to give you an idea of how this works. It's going to be, and I'm going to tie it back to interest. So imagine that our interest rate is 1 year. I'm sorry, 100%. Okay, that's never going to happen. So to turn 100% into a decimal, you write 100. This is where the decimal goes. Move it over twice, and that's going to be 1. So unless if you're a loan shark, you're never going to get that kind of interest. And this is per year. Okay. Now imagine that n is monthly. N is 12. Your interest would be 1 over 12, number of times per year, times 12 for 1 year, times t. So that would be that. And let's pretend that t is 1. Okay. So then what we would have after 1 year would be this. Okay. Now I just want to focus on this term. Okay. Let's say n is daily, so 365. This is what you would get. You would have 1 plus 1 over 365 times the 365. Again, we're assuming t is 1. Now, what I want to do is I want to compute this for various values. So I'm going to switch to Desmos. So we're going to screen share. Okay, and then I've started this out right here. So let me do a couple of things. Okay, so I want to. Okay. So notice here's x1, and this is that interest term. Actually, let me make that a little bit better. I'm going to call that n just to be consistent. I'm going to call this n. I'm going to call this n, just to be consistent. So let's say that I get paid 1 time a year. Okay, I get 2. I double my money. I get 1,000%, 100% interest per year. I double my money. Let's say that I'm going to pay it monthly. Getting paid monthly. Look how much more interest I make in a year. Okay, here I have it paid yearly. This interest term, which is 100% per year compounded daily, is now about 2.7. That's not enough. I compound it every hour. So I'm going to compound it 365 days a year, 24. So that my n is now going to be 365 times 24 here. I get 2.7182. Okay. Now again, I'm greedy. I say no. I want it every minute of every day. So it's 24 hours, 60 minutes, and an hour. So this is what it gets, 2.7. It's not growing that much anymore. Again, that's not enough for me. So I say, okay, I want it every second. And So it's 60 seconds, 60 minutes, 24 hours every day. That's how many times per day times 360. That's what the number becomes. That we really don't need this here. Okay. Okay. So anyway, so I'm going to go back now. So my point there is is that this number 1 plus 1 over n over n grows quite a bit. Okay, I'm going to go back. Okay. So again, if we let n get really large, I look at this term. And we saw that n approached about 2.71828. Okay. And actually, there's more decimals to it than that. So this number e is going to be 1 plus 1 over n as n goes to infinity. And it's a special number. And I'm going to look at this as e to the 1, and you'll see why in a second. And the way to think about it, what it is, it's getting 100% interest paid continuously. So every instant, year-round. Okay. Again, you will see this in this context in other courses. One more thing about it. So the text talks about this, e to the r, and that's going to be your interest term at r% per year, compounded all the time, so continuously. And so you might see a function like this. And what that's going to be is the interest at r% compounded continuously for t years. Okay, I'm not going to really emphasize this too much. Really what e is, this number e, we're going to have a function you'll see maybe in another class. It's called e to the t. This is the exponential function. And we are not going to get into it too much, but it's kind of like the metric system for exponents. And we can take a to the t and we can write it this way. There's a formula for doing this. So we can standardize any exponential base to e. I'm not going to go over all that here. This is getting a little bit theoretical. But because you can really cover every possible exponential function by playing around with e, that's why a lot of sciences, this is why it's used a lot. So I just wanted to say that. So if you see e again, just think back to what we said. This number e by itself is going to be interest compounded at 100% continuously for 1 year. Okay, hope that's helpful. Thank you. Bye-bye.